Greetings, digital pioneers. Today, we embark on a profound technical odyssey, exploring the crux of programming languages destined to dictate the tech pulse over the next 5 years. Get ready for intricate specs, pros and cons, corporate endorsements, developer demographics, and delightful trivia. Number 1. Python. In the world of programming languages, Python stands as a digital beacon. It's not just a language, it's a philosophy. Here's a glimpse into what makes Python a favorite among developers. Firstly, Python is a high-level marvel, soaring above the complexities of low-level coding. Its interpreted nature means that you don't have to wrestle with the intricacies of compilation. You write, you execute, it's that fluid. With dynamic typing coursing through its veins, Python embraces flexibility. No need to declare variable types, Python intuitively adapts, morphing as you need it to. This dynamic dance grants programmers the freedom to focus on logic, not type rigidity. But wait, there's more. Automatic memory management. The burden of memory allocation, Python's got your back. It elegantly takes care of memory, sweeping away the detritus of unused data, granting you the luxury of a clear mind. And the paradigms? Python's a chameleon. It bends to your will, allowing imperative instructions to flow, morphing into an object-oriented tapestry, or even embracing the functional elegance of a declarative approach. It's not just a language, it's a symphony of styles. In this digital age, where versatility is gold, Python reigns supreme. A high-level masterpiece with dynamic grace, memory wizardry, and a penchant for any programming path you choose. One of the major advantages of Python is that it's got a vast standard library and package ecosystem. With pip, Python's elegance coupled with its profound libraries like TensorFlow and Django makes it a tech jewel. However, one of the disadvantages of using Python in your projects is the GIL, Global Interpreter Lock, which can limit the CPU-bound threaded program efficiency. How are companies using Python? Dropbox uses it for back-end orchestration. Google is leveraging TensorFlow for deep learning ventures. Netflix depends on it for algorithmic features for viewer suggestions. If we want to focus on the rate of Python adoption, it's boasting an estimated 8 million strong global developer community. One fun fact is that Monty Python inspired its name, not the slithering reptile. In the US, Python developers make over $110,000 US. Number 2. JavaScript, including TypeScript. At its core, JavaScript is a prototype-based scripting language, offering a distinctive approach to building programs. It's a language that embraces the concept of objects and prototypes, allowing developers to create complex structures with ease. This foundational aspect shapes the way JavaScript code is organized and executed. But there's more to its story. JavaScript brings first-class functions to the forefront. These functions are more than just tools, they're first-class citizens in the JavaScript universe. This means you can treat functions as data, passing them around, assigning them to variables, and even returning them from other functions. It's a feature that empowers developers to create dynamic and flexible code. When it comes to handling events, JavaScript doesn't miss a beat. Asynchronous event handling is the cornerstone of its design. With the introduction of promises and the async await syntax, JavaScript takes a step forward in managing asynchronous operations. This means you can write code that executes efficiently without getting bogged down by waiting for one task to finish before moving on to the next. And let's not forget the impact of ES6, a significant milestone in JavaScript's evolution. With ES6, arrow functions take center stage, simplifying function syntax and making code more concise. Classes and modules enter the scene, providing developers with more organized ways to structure their code, enhancing maintainability and reusability. In the ever-evolving landscape of programming, JavaScript stands tall as a prototype-based scripting language with an affinity for first-class functions. Its prowess in asynchronous event handling driven by promises and async await, sets the stage for efficient execution. The arrival of ES6, with its arrow functions, classes, and modules, further solidifies JavaScript's position as a versatile and dynamic language in the digital world. However, one of the disadvantages of using JavaScript is that its type coercion can lead to unexpected outcomes. How do companies use JavaScript? Netflix depends on it for redefining UI responsiveness. PayPal revamped its platform using JS for seamlessness. Slack uses TypeScript static typing for fortifying large-scale projects. If we want to focus on the JavaScript developer community, it's a vast army estimated at 10 million developers globally. One fun fact is that its creation in 10 days resulted in quirks still discussed in JS communities. In the US, JavaScript developers make over $115,000. Number 3. Rust. In the vast realm of programming, Rust emerges as a distinct approach to building robust systems. Let's delve into the core attributes that make Rust our standout. At its core, Rust is a systems language that carries a profound emphasis on zero-cost abstractions. This means that while you revel in the elegance of high-level coding, Rust ensures that the performance does not take a hit. It's a delicate balance that underlines Rust's commitment to marrying efficiency with clarity. But there's a unique guardian protecting Rust's kingdom, the borrow checker. This feature is the cornerstone of Rust's memory safety. It watches over your code, ensuring that memory-related blunders like null pointer errors or dangling references don't infiltrate your masterpiece. It's like having a vigilant sentinel keeping your code base secure. And then there's the concept of default immutability. In Rust, data is treated as inherently immutable by default. This seemingly small choice carries monumental implications. By default, Rust is designed to ensure thread safety, which is no small feat. This means that the risk of data races and concurrency mishaps is significantly reduced, making Rust an ideal choice for building robust and reliable systems. In the grand tapestry of programming languages, Rust emerges as a systems language with a meticulous focus on efficient abstractions. Its safeguard of memory safety through the watchful borrow checker is nothing short of revolutionary. With the added layer of default immutability ensuring thread safety, Rust paves the way for building resilient systems that withstand the tests of time and use. However, one of the disadvantages of using Rust is that its stringent borrow checker can be daunting for newbies. How are companies using Rust? Dropbox uses it for data storage optimizations. The quantum overhaul within Firefox was a Rust revelation. Microsoft experiments with Rust to diminish C++-induced vulnerabilities. Rust is growing rapidly. It has a dedicated base of around 100,000 developers. One fun fact is that it's not just a fan favorite. Rust has been most loved on Stack Overflow consecutively. In the US, Rust developers make over $125,000. Number 4. Go. Go is also known as GOLANG. It's time to unravel the distinct characteristics that make Go a true gem in the programming world. First and foremost, Go is a statically typed language that wields the power of compilation. This means that errors are caught early in the development process, ensuring a smoother journey from code to execution. Alongside this, Go comes equipped with garbage collection, which is like a digital janitor tidying up unused memory and freeing up resources for more important tasks. But that's not all. Go thrives in the realm of concurrency. It's a language that embraces parallelism and multitasking. How? Through the ingenious use of Go routines and channels. Go routines are lightweight threads that allow you to execute multiple functions concurrently. These Go routines communicate through channels, creating a synchronized dance of data that maximizes performance and efficiency. And let's not forget Go's interface-based type system. It's like a set of blueprints that define structure and behavior of your code. By focusing on interfaces rather than strict inheritance, Go promotes flexibility and extensibility. It's a design philosophy that empowers developers to craft code that's adaptable and modular. In the grand symphony of programming languages, Go takes center stage as a statically typed, compiled marvel. Its mastery of concurrency through Go routines and channels sets it apart, enabling efficient multitasking. The interface-based type system adds an elegant layer of flexibility, allowing developers to craft code that evolves and adapts. This is the essence of Go, a language that doesn't just code, but orchestrates a harmonious digital experience. However, one of the cons of using Go is that it historically lacked generics, which is mostly available in other languages, though recent versions are addressing this. How are companies using Go? Uber depends on it for surge pricing algorithms. At Google, Kubernetes, the container orchestration giant, is Go-powered. BBC is adapting Go for robust digital content delivery. Go's growth is stellar, with nearly 2 million developers globally. A fun question about Go for you guys. Why a gopher as a mascot? It's a play on Go for, indicative of its fetching capabilities. In the US, Go developers make over $140,000 US. Our digital lexicon is vast, with languages like Swift, Kotlin, and Java, each singing their own algorithmic symphonies. The digital era is propelled by these coding maestros, and their stories are far from over. Dive deep, unravel the codes, and script the future. Like this digital journey? Smash that like button, spread the word, and don't forget to hit subscribe. Goodbye.